Hello, welcome to my channel Wonderful SQL. So I wanted to start a series of performance tuning videos. So for that, the basic things we should be knowing is indexes. So let us start with indexes. Indexes are mainly of two types. So which are called as clustered index and a non-clustered index. So both the indexes are implemented via balanced tree data structure, which is also known as B tree. The B tree contains a root level, intermediate level, and a leaf level. So if you wanted to see how it looks, so this is how a B tree looks. Like this is the root, and then the next comes the intermediate levels. These two are intermediate levels, whereas these four are the leaves. So this is how the B tree looks. So we are not going detailed into B tree. So that is a vast, and this is completely different because that depends on that is the data structures topic. So we will not go deep in that. So coming to clustered index, a clustered index is in a simple English or simple words, we can say that physically in which order you want to store the data in a table. Physically means once a data is stored there, that is stored in a permanent way. In a permanent way, like in an order where using some column, or in a you can sort the data using any column, like numerically, alphabetically, or whatever way you want to. So then in general, when we insert the data in the table, it's not sorted in any order. So when we create a clustered index, it will be sorted in the order on which the clustered index is created. So on that column is used for sorting the data. So only one clustered index we can have on a table, because it is how you want to see the data physically on a drive. So it can have only one clustered index created on a table. So coming to example, if you see your mobiles, the contact numbers are in an alphabetical order. So they are clustered. They are also called like a clustered index. And when you look at a rack of books where we place the books in an alphabetical order starting from A to Z, that can also be called as a clustered index. So that is physically stored in the rack. So you can have only one clustered index, which means only one way you can store, either in alphabetical order, in ascending or descending. So only two things we can do in that case. So similarly here, the physically the data is stored, so we can only have one clustered index on that. So we will see how the picture looks for a clustered index. So when you look at the picture of a clustered index, so this is the root level, this is the intermediate level, and this is the leaf level. So as I said, the root level will store the index values. Like suppose if you have created the table and using the column of an integer type, so that is used for creating an index key. So that key, suppose you have 10 numbers in that column, like 1 to 12. So the root level stores the what is the range, then the intermediate level shows the way to the data which are stored actually on the leaf pages. So here 1 to 12, and the intermediate level says 1 to 6. So then you go deeper into the tree, 1 2 3 are in this node, and 4 5 6 are in this node, and the actual data is stored in the leaf. So this is how the clustered index looks. I'll tell you with an example which will be more clear. So let us go to an example, see an example. I'll create a table called student with ID, name, gender, and city. So we create a table. So we have created it. There is no index or anything on this table. It is just called as a heap, because no clustered index, no primary key, or no non-clustered index. So we can call it as a heap. And one more important thing is, when we create a primary key on the table, the clustered index is created automatically. We need not derive a clustered index on that, because the primary key will create a clustered index on that table. So let us see how the data looks in this table. So I have inserted, I did not sort the data while inserting. If you see 6 2 9 3 1 4 7 and so on, so we can see that this data is not in sorted order, we have inserted into the table. So let us see how the data looks in a table now. sorry, I have created the table but did not insert the data yet. So let us insert the data. So there are 10 rows now. So let's see how the data looks on the drive. So it is inserted as in the same way or same order which we have inserted. So now you see, so whatever the order in which we inserted, it is stored in the same way. But when we create a clustered index on this id, let us see how the data looks. So I'm creating a clustered index on id, so it is created. Now if you see, so they are in sorted order. So this is how a clustered index works. And you might think that now if I insert something like there are 1 2 3 4 5, all the 1 to 10 integers are inserted. So if you insert something like a new record, and see, sorry, so now I have inserted a new record, and if you see, it is inserted after 10. So now let us insert 11 and see whether this is going to sort it by itself, or it will insert under 12. So let us see now. So if we are inserting now 11 under 12 after 12, so we will see where it goes. So now we have inserted, sorry, I have inserted it twice, but let us see where the record is inserted. So if you see now, 11 is inserted before 12, so automatically data is getting sorted in the order of this column. So id used for sorting the data in this table. And when you query the data, so if you wanted to see the statistics, suppose we wanted to, we will see once when we do not have a clustered index or any index on this. So we will just drop this index and see how the execution plan looks if you don't have an index. So I'm dropping this index. Okay, now we have dropped it, and we will see how the execution plan looks. So it is just a table scan because there is no index on this table. I have deleted the index or dropped the index. So you can see that this is just a table scan. So this is known as an operator. Going further on performance tuning series videos, so we will discuss deeply on these operators. There will be table scan, index scan, and index seek. What are all these and how they help us in tuning the query. So let us not go deep into this now. So we will go further on this in the next videos. So now it is doing a table scan, which is very much time taking because every record will be scanned. So now our query is not so complex, so every record anyways we are fetching. So now we will create an index. So we have created an index. Now if you run this query, what happens? Let us see. Now it is just a clustered index scan on id. So whatever the cluster index we have created, it is using that to pull the data from the table. So we can say the table scan has become an index scan now. So similarly we'll see for non-clustered index. So let us go back to see what we have for non-clustered index. So a non-clustered index is the logical way of storing the data. So we can have as many as have 999 non-clustered indexes on a table. Because here the data is just a logical way of storing, which means there is no physical existence for that index. So we can have more than one non-clustered index on the table. So the limit is 999. And having an index on the columns, on the columns which are regularly used and which are not part of clustered index, will help us to reduce the amount of CPU or memory required, as additional sorting will not need to be done. And I'll tell you with an example. So since the data in the index is already ordered, so as the data in the index is already ordered, we are sorting the data in a logical way. When we are querying those tables using the columns which are part of non-clustered index, will help us to reduce the amount of CPU or memory required. So that will help us to gain some time when we are querying huge tables. Now I cannot show you the time difference in my SQL Server instance, because this is just adventure works, so we cannot see the data time difference, but you can observe that on the production databases when you are working. So now we'll see. Let us think that we did not create any index yet, so we just query the id column. So it takes index scan on clustered index. So now we are creating a non-clustered index on the name column. So now if you wanted to use id in the where class, but we are getting name, so let us see what is used. So it is using the clustered index on the index id which we created, because in the where class we are using id. So let us see, if you wanted to use name, and on the name we have a non-clustered index. Now we will see how the execution plan looks. So it is now using index seek, which is very faster compared to index scan. So it is using the non-clustered index which we have created on the name. So when does this non-clustered index comes into the picture is when you are using a condition, a where condition on order by or a group by on the columns on which we have created a non-clustered index. So this helps in finding the data which we want relatively easily or faster. So it helps in tuning the queries. So we help these we use these indexes and create the. So using these indexes, we can fine tune the queries which we are using on a production environment or an acceptance environment where you wanted to test your queries. But when the volumes are huge, we can see a big difference. And this is how the indexes work. So in the further videos, we will see the exact functioning of the operators which I mentioned in the earlier, like index scan, index seek, or table scan. So these are the operators we are going to discuss further. And what are these physical operations, logical reads, physical reads, estimated input output cost. So everything we will be discussing in the later videos. So this is what. And when you look at the b tree of these, so clustered index I said, so the root level will contain the root level will contain the index keys. Here the index key is the id which we used to create the index, a long clustered index. So this is the key. So 1 to 12, the here 1 to 6 on the left node, and 7 to 12 on the right node. So going further, this is the intermediate level, and going further into the leaves we see that 1 to 3, and here are the actual details of those ids and their related columns. So this is how the data stored on a clustered index. So the intermediate level and the root level will contain the index keys, whereas the leaf contains the actual data. So when you go into a non-clustered index, the intermediate level and root level will contain the index keys, which is the name column which used. So we are taking it A to Z. In the intermediate level, it is further stored, divided the data. I mean the like A to M and N to Z. When we go to the root levels, here comes the difference. So here, as it is a logical way of storing the data, we are just storing the index keys in the root leaf level. So if you see, these are the index keys in the clustered index. If you see 1 to 12 are the index keys, and these are stored in the leaf level and related data here in the leaf level. So in the non-clustered index, when you see, this is the index key, non-clustered index key, and here the data is not stored. Actually, it is the indexed key which is stored, and it is used this index key to fetch the data from the actual table. So I'll show you in a picture which is very clear. So but before to that, we see, if no clustered index is created on a table, so you might get a doubt that if there is no clustered index, what is stored on the leaf nodes of a non-clustered index? It is then the row identifier is stored in the index. Row identifier is nothing but a unique identifier to identify each row in a table when there is no clustered index or non-clustered index or whatever it is. Just it's a heap. Whatever I said in the earlier, heap means there is no clustered index, no primary key, no non-clustered index. So there is nothing, just a raw table. So then each row can be identified using a row identifier. So here the row identifier will be stored for reference to fetch the data from the table. So this is how the non-clustered index work. So let us see how it looks. So this is the best picture I got from Google. If you see, this is the root node, intermediate node, and leaf node where the actual data is stored. So this is how a clustered index works. And when you see a non-clustered index, root node, intermediate node, then comes the leaf node. No data will be stored, but it is pointing to the leaf node where the actual data is in the table. So here, so the leaf nodes of non-clustered index contains the pointers to data stored in clustered index. So as I said, if there is a clustered index, then it will be pointing to the leaf nodes where data is stored. Or if there is no clustered index, then it uses the row identifier to identify the data, because we can have a clustered index and non-clustered index on a table both, and we can also have only a non-clustered index. In that case, it uses the row identifier, so that will help us to identify the data faster. So this is how a non-clustered index and a clustered index works. So going further, we will be seeing operators like index scan, index seek, and table scan. What are the difference and how it helps? So if you have any further suggestions or you wanted to know anything more on this, please comment on my video, and I'll try to answer all those questions with a new video in the coming weeks. Thank you.